Okay, ladies, this is 4.1 and it's about graphing quadratic functions. So we have a few key vocab terms that we're just going to list here on this page. So our first term is quadratic function, and that's a function that can be written in the standard form y equals ax squared plus bx plus c. And then a parabola is the graph of the quadratic function. The next term, vertex, that's the lowest or the highest point on a parabola, and it's a coordinate. And then axes of symmetry, that's a line that divides the parabola into mirror images. And it will always pass through the vertex. And you're going to see it as x equals something. All right, then our minimum value, and that's for this equation here. So for this equation, our minimum value is the y coordinate minimum value is the y coordinate if a is greater than 0. And then we have
I don't have my compass.
So the maximum value is that same quadratic standard function, but you're looking at the y coordinate, and if a is less than 0, you're going to have a maximum value. Because for the maximum value, your graph has to be pointing down, going down, opening down forever, and then your minimum value, your graph has to be opening up. So these next few, I want you just to pause the video if you haven't done this already and plug these values into your calculator and then tell me what the vertex is, whether it opens up or down, if it's wider or narrower than y equals x squared. So please pause the video, plug these values into your calculator, and we're going to look to see, you should make some kind of generalization related to your vertex and related to your whether or not it's wider or narrower and whether it opens up or down. Please unpause for the solution. So here's what you should have discovered when you put these values into your calculator. All of these vertices are 0, 0. Those are the coordinates. The x and the y are both 0, 0. And then the ones that open up, so that's x squared, 2x squared, and 1/3 x squared. All of these values are when a is positive. The ones that open down, all of these values are when a is negative. So if a is negative, then the graph will open down. Now looking at the wider and narrower, these two are narrower, and that's when the absolute value of a is less than 1. and these two are wider. So that's when the absolute value of A is greater than 1. And if A is equal to 1, you'll end up with something that's neither narrower or wider than the x squared graph. Okay, so looking at this next key concept that you have in your handouts, the axes of symmetry. In this graph, the y-axis would be your axis of symmetry. So that's when x equals 0. This vertex here is 0, 0. So x equals whatever the x coordinate of the vertex is. That is your axis of symmetry. So x equals 0 in this case. So this next part we're going to compare, just like we did with our warm-up exercise, we're going to compare with the graph of y equals x squared. So again, I want you to pause this video while you plug these values into your calculator, and then I want you to say whether it opens up or down, if it's wider or narrower, and what's the vertex. So please pause this video while you work and unpause for the solution. So the first one, y equals negative x squared, this A is negative, so it's going to open down. The A is 1, so it's negative 1. So it's not going to be wider or narrower, so it's going to be the same. And lastly, the vertex is 0, 0. For this next one, our A is positive, so it's going to open up. Secondly, the absolute value of A is greater than 1, so it's narrower. And lastly, the vertex is 0, 1. So let's see if, without even doing this on our calculator, without even looking at your calculator, we can make these conclusions. So here, because this is negative, we know it's going to open down. Because this is less than 1, we know it's going to be wider. And here is our vertical shift down 2 units. So the vertex is 0, negative 2. Now, in these cases, this C value has been our y-coordinate of the vertex. However, that is not always going to be true. So we can't generalize with that, but we've got a new formula for a quadratic equation that we will be able to generalize our vertex. However, C is not always the y-coordinate of our vertex. So some general rules that we have for the quadratic function is the parabola opens up if A is greater than 0, and it opens down if A is less than 0. So that's just the conclusions that we've drawn so far, but now we're going to make it into a general rule. So again, if A is greater than 0, like here, positive, it's going to open up. If it's less than 0, like here, it's going to open down. The parabola is going to be narrower if the absolute value of A is greater than 1, and it's going to be wider if the absolute value of A is less than 1. So again, we saw that in the graphs that we did. Here, absolute value of A is greater than 1. Here, absolute value of A is less than 1. And then the x-coordinate of the vertex, which we haven't dealt with yet, but is negative b over 2a. This should look familiar. It should look like your quadratic formula. So you should, this equation here, negative b over 2a, should at least look familiar. It should remind you of the quadratic formula that you used last year. And then the axis of symmetry is the vertical line, and again, it goes through the x-coordinate of the vertex. So it's the vertical line x equals negative b over 2a. The y-intercept is going to be your c value. So the point 0, c is always going to be on your parabola. Okay, let's look now at some graphs. So when we're graphing parabolas, the first thing we want to do is identify our A, our B, and our C. This will just help us keep all of our information organized because there's a lot going on graphing these parabolas. So our A equals 2, B equals negative 8, and C equals 6. So this is ax squared plus bx plus c. The next step is to find the x-coordinate of the vertex, which is negative b over 2a. So in this case, it's negative 8, which is 8, over 2a, which is 4. So 8 over 4 is 2. Now that's our x-coordinate of our vertex, but that's not the only coordinate we need. We also need the y-coordinate. So to find the y-coordinate of our vertex, we have to plug in the x-coordinate to the quadratic function. So y is 2x squared, which we said our x is 2, minus 8 times x, which again in this case is 2, plus 6. So we need to find our y-coordinate. 2 times 4 minus 16 plus 6. So that's negative 8 plus 6, which is negative 2. So our vertex now is 2, negative 2. Now we need to graph the vertex. So we're just going to plot that point, 2, negative 2. And the next step is to draw the axes of symmetry. Okay, so the axis of symmetry goes through the x-coordinate of the vertex, and it's a vertical line. So x equals 2. And then we want to decide whether the parabola opens up or down. This is just going to help us so that when we actually graph it, we can kind of do like a quick assessment of whether or not this looks right. So in this case, since our A is 2, which is greater than 1, or it's greater than 0, so it's a positive number, that means that our parabola is going to open up. So it should look something like this. It opens up. Okay, and then the next one is to plot 2 points on one side of the vertex. So I'm going to do 1 and 0. Okay, so now you need to actually plug these values in. So 2 times 1 squared minus 8 times 1 plus 6. Actually, just move this down. So that's 2 minus 8 plus 6, which is 0. So 1, 0, that's 1 point. And then my next point, I'm going to pick 0. So that's 2 times 0 squared minus 8 times 0 plus 6. So 2 times 0 squared is 0 minus 0 plus 6 equals 6. So my 2 points that I'm going to plot are 1, 0 and 0, 6. So 1, 0 and 0, 6. Then the next step is to plot the symmetry points. So here's the symmetry point, and here's the symmetry point. And then lastly, I'm going to actually draw in my graph. And it goes forever this way. So this point right here, this is my minimum value. I have a minimum because my parabola opens up. So my minimum is -2. For your minimum, you're always focused on the y coordinate of the vertex. So in this case, we have a minimum. If it opened down, then we would have a maximum. And we don't really care about our x values because our x is going to go forever this way and forever this way, because every time we go up a little bit, we go over. Every time we go up here, we also go over. It's just a little bit, and it gets smaller every time. But when we get to infinity as our y value, we're going to have negative infinity as our x value and positive infinity as our other x value. So really the only place it stops is right here at this vertex. Okay, so I want you to try this one on your own, and I'll walk through it after you unpause the video, but try it on your own first, and then follow all of those same instructions as we did from example 2, starting with identifying your A, your B, and your C. So to start, our A is -1, our B is 4, and our C is 5. The second step is to find the x-coordinate of our vertex, which is -b/2a, so our x-coordinate is 2. The next step is to plug our x value into our equation to get our y-coordinate of our vertex. So if we do that, we end up with 9. So then we can say the vertex equals 2, 9. And then we can plot that point. So here we go, 2, 9. Next step is to draw our axis of symmetry, which is our x-coordinate of our vertex. So that's the line x equals 2. So it should go right through your vertex. Okay, our next step is to determine whether this opens up or down. So if we look at the formula, our A is negative, so we know it opens down. Then our next step is to find 2 points on one side of the vertex and plot those coordinates. Right, so the 2 points that I chose were -2 and 0. So if I use -2 as my x value, I get a y of -7. If I choose 0 as my x value, I get 5 for my y value. So now I need to plot those 2 points, -2, -7, and 0, 5. And then I need to plot the symmetry points. And then I can draw my parabola. It should be more of like a curve or a point. And it goes forever down. That means that this point right here, y equals 9, that's my maximum value. Y is not going to go above that point at all. Okay, so that was all for the lesson, but now we're going to look at story problems and how we're going to actually set up these quadratic formulas or quadratic functions. So this case is a video store. It sells 150 DVDs a week at a price of $20 each. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold. For every $1 decrease, we're going to sell 25 more DVDs. So how can the owner maximize the weekly revenue? Well, first we need to figure out, okay, how do we measure revenue? So our revenue is measured by the price of our product number of units sold. So if we're selling a cup of lemonade and we're selling it $1 a cup of lemonade, if we sell 3 cups of lemonade, that's the price, $1 times 3 cups of lemonade, $3 revenue total. Okay, but this is a little bit different. So we're working with increasing price and selling more selling less DVDs, or decreasing price and selling more DVDs. So our price is $20. That's what we're starting at. But we're going to decrease our price X dollars. We don't know how much we're going to decrease yet, but our price is going to be starting at 20, and then X is the number of dollars we decrease. Now, the number of units sold starts at 150, and we're going to sell more every time we decrease our price. We're going to sell 25 more DVDs. So if we were to decrease $1, so our price would be $19, our number of units sold would be 150 plus 25 more, because every decrease in price sells 25 more DVDs. So this right now is in what we call intercept form, or almost intercept form. We need to get it into standard form because that's the form we're working with in this lesson. So we need to FOIL. So 20 times 150, that's 3,000. And then outside terms, it's 20 times 25, which is 500x. And then the inside terms, and then the last terms. Oops. Minus 25x squared. Okay, so this is how we're going to model our revenue. Now I'm just going to rearrange this so that it's in a form we recognize, because usually we have our x squared first. So I'm just going to rewrite it just so that it's in a recognizable form. Negative 25x squared, and I'm going to combine my like terms while I do that. Plus 350x plus 3,000. Now the question is, how do we maximize revenue? What do we need to do? So we need to figure out how many dollars are we going to decrease the price of DVDs. So in order to do that, we need to find our vertex. So our vertex is negative b over 2a. So negative 350 over 2 times negative 25. So our x is 7. So we need to decrease the price of our DVDs by $7. And if we do that, we maximize profit. So if we decrease the price of DVDs by $7, and if we look at our parabola, we get a revenue of $42.25. So you have to be careful reading the problem, because it's not asking you what our maximum revenue is. It says, how can we maximize revenue? So in this case, we would just say that we can maximize revenue by decreasing the price of DVDs by $7. So maximize revenue by decreasing the price of DVDs by $7. So we sell DVDs for $13 each to generate weekly revenue of $4,225. So please jot down any questions you have from this lesson, and we can go over them next time I see you in class. Thank you.